in this lesson, we are going to solve this question I have on the screen. The question says that the man has a weight of 150 newtons and jumps onto the boat which has a weight of 200 newtons. If the man has a horizontal component of velocity given as 3 meters per second relative to the boat just before he enters the boat, and the boat is traveling at a speed of 2 meters per second away from the pier when he makes the jump. Determine the resulting velocity of the man in the boat. So that's the question. So let's analyze this question very well. In the question, we're given the weight of the man. Okay, so which I write as weight of the man, which is given to be 150 Newton, and then the weight of the boat, which was given to be 200 Newtons. Okay, and then we've been told that the man has a horizontal component of velocity v, which is given as 3 meters per second relative to the boat just before he enters the boat, and then the boat is traveling at a speed of 2 meters per second. Okay, so the velocity of the boat is given as 2 meters per second. So we have to determine the resulting velocity of the man and the boat. Okay, so now for us to determine the resulting velocity of the man in the boat, we are going to apply the principle of conservation of momentum, which states that if two bodies collide, then the total momentum before and after the collision will be the same if there is no external force acting on the colliding object. So this is the principle that we are going to apply here, and we know that momentum equals the product of mass and velocity. Okay, so the principle of conservation of momentum states that if two objects collide, then the sum of their momentum before collision will be the same as what? The sum of their momentum after collision. So let's say I have an object which has a mass m1, and then I have another object which has a mass of what? M2. Okay, and then this object m1 here, okay, has an initial velocity of what? u1, and then the mass m2 also has an initial velocity of what? u2. Okay, so these two objects have their initial velocities. So the initial momentum, okay, for each one of them will be m1 u1, and then that of the mass 2 will be, that will be plus m2 u2. Okay, so this will be the sum of the initial momentum. Okay, so this will be the sum of the initial momentum, and that will be equal to the sum of the momentum of what? The objects after the collision. So that will be equal to m1 v1 plus m2 v2. Okay, so this is what the principle of what? Conservation of what? Momentum says. Okay, so what happens here is that if the collision is elastic, okay, what that means here is that after the two objects collide, they will separate. Okay, that means what? They are elastic. If the two objects are, if the collision is elastic, then that means what? The objects are going to separate after collision. So in that case, they are going to have different velocities. Okay, so in that case, they are going to have what? Different velocities after the collision. If the collision is inelastic, then the two masses are going to remain stick together after the collision. So in that case, they are going to have a common velocity. So that will be m1 u1 plus m2 u2. And then since we are talking about inelastic collision here, that means what? The two objects are going to have a common velocity at the end. Okay, since they are going to stick together after the collision. So in that case, you are going to have m1 plus m2 times what? The final velocity Okay, since they are sticking together. So let's take note of this. So with the knowledge we have now, let's go ahead and then answer this question. So from the data given to us, we know the velocity of the boat, we know the velocity of the boat, and then we know the velocity of the man relative to the boat. Okay, we know the velocity of the man relative to the boat, but we don't know what the actual velocity of what of the man. So all we have to do is to calculate for the actual velocity of the man. So how are you going to do this? So the relative velocity of the man, okay, with respect to the boat is given as v. Okay, is given as v, and that's equal to the velocity of the man with respect to what the boat. Okay, and that will be equal to what the velocity of the man minus that of the boat. Okay, so you are going to have v because vm vm okay minus vb. Okay, but we know v and then we know vb, but we don't know vm, so I'm going to make vm the subject. So I'll have vm equals v plus vb. So that will be the actual velocity of the man, and we know these values, so let's substitute them there. So the velocity of the boat is given to be 2 meters per second, then the relative velocity of the man with respect to the boat is given to be 3 meters per second. So I'm going to have the actual velocity of the man to be equal to 5 meters per second. So the velocity of the man is actually 5 meters per second. Okay, so that's for the velocity of what of the man. And then we know that what momentum equals what the product of what mass and then velocity. Okay, so in the question we were giving weight, we were not giving the mass of the man and then the boat. So you have to calculate for the mass of the man and then that of the boat. So we know that weight equals mass times acceleration due to what gravity. So mass will be equal to what weight over the acceleration due to what gravity. So for the mass of the man, okay, for the mass of the man, that will be the man's weight, which is 150 divided by acceleration due to gravity, and that's 9.81. So let's find the value of this. So that will give me a value of 15.29. Okay, 15.29, and the unit is grams. Okay, so that's the mass for the man. And then let's calculate for the mass of the boat also. So the mass of the boat will be equal to 200 Newton divided by acceleration due to gravity. Let's look at that also. So that gives me a value of 20.387. So let's make that 20.39 grams. So that's the mass of the boat. So we now have all the data that we need to answer this question. So for the mass of the boat, that's 20.39 grams, and then that of the man, okay, the mass of the man is given as 15.29 grams. Okay, so that's the mass of the man. So with this data, let's go ahead and then answer our question. Okay, so what's happening here is that the man is jumping into the boat. Okay, so there will be a collision there. And then what happens here is that after the man has jumped into the boat, they are going to move together with the same velocity. Okay, they are going to move together with the same what velocity. So that's an inelastic collision. So in that case, they are going to have a common velocity after the collision. So the sum of the initial momentum of the man and the boat will be equal to what? The sum of what? The total momentum. So let's apply that here. So we are going to have the momentum of the man. Okay, so that will be the mass of the man times velocity of the man, okay, plus the mass of the boat times the velocity of the boat. That should be equal to what? The total momentum. Okay, so in this case, they're going to have a common velocity after the collision. So that will be the mass of the man plus the mass of the boat, okay, times the common velocity, which I name as what? Vf. Okay, so now we know all our values and then we want to find Vf. So we just have to substitute in all our values. So the mass of the man, we got it to be 15.29 grams times the velocity of the man, which is what? 5 meters per second, plus the mass of the boat, which is 20.39 times the velocity of the boat, which is what? 2 meters per second. And this will be equal to what? The sum of the masses. That was 15.29 plus 20.39. Okay, then the common velocity. So let's simplify this. So 15.29 times 5 plus 20.39 times 2. So this will give me a value of 117.23. Okay, this will be equal to 15.29 plus 20.39. That'll give me 35.68 VF. So we divide both side by 35.68. Divide both side by 35.68. So this will cancel out this. So then I'll have 117.23 divided by 35.68. So that'll give me the final velocity for the boat and the man to be equal to 3.28559. I'll write that as VF equals 3.29 meters per second. So this will be the final velocity of the man and the boat.